Hello everyone, this is my class on convergence and divergence. How to test whether the given series is a convergent or a divergent series. I have already handled two classes, two videos. I have put two videos or two lecture classes I have given on convergence and divergence. This is my lecture 3 and today let us see two problems in convergence of a series. Now you see that this is lecture 3. This is lecture 3. See, this is the series given. You are given the series. Now I will use comparison test. Let me use comparison test to verify, to check whether the given series is convergent or divergent. So my idea is to use this comparison. Now what is this comparison test? You consider two series like this. See, let me consider two series. It is sigma of un of positive terms. Sigma, this is a series 1 to infinity. Sigma un is a positive term series. And sigma Vn is also a positive term series, and if limit of n tending to infinity of un by Vn, this un is nothing but the nth term of this series and Vn is the nth term of the series sigma of 1 to infinity Vn. If this is equal to say some L, a positive, that is a positive quantity greater than 0, then either both sigma of un and sigma of Vn converge, or both diverge together. So this is the what is called the comparison test. So the comparison test says that you are given a series sigma of un, which are all terms are positive only. Every term is a positive term. Likewise, you take another series which is also containing positive terms. If it so happens that limit of n tending to infinity of un by Vn, where this un is nothing but the nth term of the first series and Vn is the nth term of the second series, and if we take the ratio of this and allow n tend to infinity, and if we get a finite limit, this is a finite limit. And if it is greater than 0, then either both converge or both diverge. So this is what is called the comparison test. Now let us use the comparison test here and then in this and prove that whether this is a convergent or divergent series. Now what is the series given? See, in all these problems that we are going to see here, you must note one thing, that writing the nth term is very, very important. That is, the art of writing the nth term is very important. Only when you know how to write the nth term, you can proceed with the problem. Okay. Now, what is here now? So in this, S can be written as, see, I will write what is my nth term. What is my nth term? So what is your un? Nth term of this. So it starts with 2 2, 2. So it contains 2. And this is 1 cube, then 2 cube, then 3 cube. So naturally you see that it is n cube plus 5 is there, divided by this 4 comes throughout, 4 into, and this is also 1 to the power of 5, 2, it is 2 to the power of 5, and so it is n to the power of 5 plus 1. And so therefore what is this series? So it is n is equal to 1 to infinity of, see, you give 1, it is 1 cube plus 5, you are getting. So the series starts from 1 and it goes up to infinity. Un will be equal to sigma of 1 to infinity of 2 into n cube plus 5 divided by 4 into n to the power of 4. Now this is a series. So I am able to get what my un is. So having known this un, let us now write what is my un. Now un is equal to, so this I can write this as 2 into n cube plus 5 divided by 4 into n to the power of 5 plus 1. When the first I take this, the n cube, the highest power outside, 2 plus 5 by n cube. Then this is divided by n to the power of 5 within brackets 4 plus 1 by n to the power of 5. Now this is nothing but, so this is nothing but 1 by n square, and this is 2 plus 5 by n cube divided by 4 plus 1 by. Now, so we can choose conveniently, you see that this is 1 by n square. So I can conveniently choose, say you choose this, say this is n cubed by n square, so you are getting one, choose your Vn is equal to 1 by n square. 1 by n square. Therefore, what is that you will get here now? Therefore, un by Vn will be equal to 1 by n square into 2 plus 5 by n cubed divided by 4 plus 1 by n to the power of 5 into, see, divided by, this is divided by 1 by n square. So you see that this will be equal to your n squared by n squared into 2 plus 5 by n cubed divided by 4 plus 1 by n to the power of 5. So what is that you get here now? So what is that you get? So your un by Vn, see, un by Vn will be equal to, this is 2 plus 5 by n cubed divided by 4 plus 1 by n to the power of 5. Now you take n tending to infinity, that is, you take n tending to infinity, limit of n tending, therefore is equal to limit of n tending to infinity of 2 plus 5 by n cubed divided by 4 plus 1 by n to the power of 5. So if you apply the limit 1 by n is equal to 0, 1 n tends to infinity. So this becomes 0, this becomes 0. It is 2 by 4, that is equal to half. It is a positive term and it is greater than 0 and positive. And therefore, see, and therefore you see that the two is un and Vn must both behave in the same manner. Must behave in the same manner. But we know that, See, 1 by n square, Vn. See, but we know that Vn is equal to sigma of 1 by n square. N is equal to 1 to infinity is a convergence series by p test. By p test. Therefore, so I told you that comparison test, either both of them converge or both of them diverge. They will behave in the same manner. Now we have found that this Vn sigma of n squared is a convergence series, and therefore sigma of un 1 to infinity, namely S is equal to sigma of 1 to infinity un, this one, see, that is 1, that is 1 is a convergence series. So this is how we do this. I will do more problems in this, taking some difficult problems. So you see that this is very straightforward. You must know that how to write the nth term. That is the art of writing the nth term. If you can write the nth term, you see that after then, only if you know how to apply the test, it is nothing but simple. So here I have used only the way how to write the nth term and then compare it with 1 by n square. I could very easily compare it with 1 by n square, because then only I can apply that n tending to infinity so that I can get a definite limit. See, this to half I could get. So you see that 1 by n square, as we know, the series sigma of 1 by n square is a convergence series using the p test series, which is sigma of 1 by n to the power of p. So this sigma of 1 by n to the power of p will tend to definitely it will be a convergence series provided p is greater than 1. Here it so happens that it is 1 by n square. Therefore it's a convergence series. Hence this series. Now on comparison, hence this series should also be a convergence series. So this is all about the first problem. Now let me pause on to the second one. Second one I will do this. See, second one, it's a simple problem only. So this is actually a series. See, this is actually a sigma of an. Sigma of an 1 to infinity of this is equal to sigma of 1 to infinity of cos of n square pi divided by 3 n square plus 1. This is pi here. So we have to find whether this is a convergent or not. So as we here it is straight away it is given that nth term. Otherwise, if they give you say cos of pi by 3 plus 1 square plus cos of 2 square, see 1 square pi divided by like this. See, if they give you the full series, you should be in a position to correctly write the nth term. But here in this problem, straight away it is given the nth term, so there is no need for you to worry about that. Now it is simply how to determine whether the series would be is a convergent or a divergent series. Now let me take this. Now what is your an? An is equal to cos n squared pi divided by 3n squared plus 1. Now, say what is that you do now here? So this is equal to, so this is very simple. Cos, you take this n squared outside, then pi divided by, take this n squared outside, 3 plus 1 by n squared. This is what you get. Take this n squared outside so that you get 3 plus 1 by n squared. So this n squared and n squared will go off, giving you cos of pi divided by 3 plus 1 by n squared. Now you take the limit as n tending to infinity, n tending in infinity of an will be equal to limit of n tending to infinity of cos pi divided by 3 plus 1 by n square, which is equal to cos limit n tending to infinity of pi divided by 3 plus 1 by n square. So you see that what happens is this 1 by n will tend to 0. As n tends to infinity, this 1 by n will naturally will tend to 0 because we know that this is a. So you see that what is that you get here? So you get simply cos of pi by 3. Cos of pi by 3 is nothing but what? Cos 60 degrees, which is equal to half. So it's a finite limit. So you see that finite. Therefore, so n tending in an is equal to half. Therefore, the series, therefore, sigma of an 1 to infinity is a